Hello. Hello and welcome to this video. In this video, we will learn about integers and floats. So integers are whole number and Python are numbers with fractional parts. So let's first look at what we can do with integers. So for example, we can add them, we can subtract them, obviously we can multiply them, and similarly we can divide them. Now, when you divide, something special will happen, okay? So let me run this. Control F5. And we have 404 and 1.0. So this is a floating point number, okay? What this means is if you divide 3 by 2, then it will print 1 by 1.5, okay? Now, if we only want integer side of this, we can say 3 by 2. If you want only integer, then it will print 1. Okay. We have more operators, like we can do exponentiation. So this will print 8. Okay. Now we can do all that. If you want more functionality on integers, then what you should do is you should import math module. Okay. And you will see there are lots of things in math module. We have a cos h, a sine, a tan, and so on. Right? There are lots of functions which you can use. So one of the functions I would like to bring to your attention is factorial. So if you evaluate factorial 5, it would give us 120. Oh, I have not printed. We need to print it. And math factorial 5. So if you print it, will print 120. Now suppose we want to print a large number, let's say factorial of 10,000. Can you print this? So it says there is a problem. The problem is that the limit on the number of digits is 4,300, but we are crossing that. So it is asking us to set the limit using this function, okay? So we'll do that. And what we will do is we will import sys, and we will say sys dot set underscore int max str digits. We will set it to say 50,000. Okay. Now we run this, and we have our float. It's a big one. Let me show you the function. So see, starting from here, it prints all the factorial of 50,000. Now, if you are from, say, C background or C++ background and you don't have big num facility in your language, then it is a big problem to calculate such a large factorial. You will need to implement the big num library, and therefore it is complicated in those. So Python gives you this facility out of the box. Now, what this means is that it cannot be a typed language. It is the feature of a typed language that you associate a type. And if that type is a primitive type, like it has a fixed width, 64-bit or 32-bit or 128-bit, there will always be an upper limit. For example, with 32-bit numbers, you can go up to 2 to the power 32 minus 1. And with 2 to the power 64, with 64 bits, you can go up to 2 to the power 64 minus 1. So at most, you can compute something like 20 factorial of 20 in C with 64-bit integers. That problem is not there. The reason why this problem is not there in Python is because we need to look at what is an integer. Okay, so we want help on integer. Let me comment this out. We don't need this anymore. So now if you run print help int, you will get the help of int. So what is an integer here? So integer is a class. It's a complicated thing actually. I will show you possibly in the next video the source code of int object and float objects, and you'll see how complicated the implementation is. It provided lots of methods of its own. Most of these methods are for operator overloading. Some are for uh, computation of ceiling and floor and all that. And most of these are used for uh, mathematical operations. For example, I can compute math.ceil of, let's say, 5.2. We have to import math for this and we print this, okay? Now we don't need this. So okay. So why it started 10 and it should have started that. Control Alt F5. All right, so it prints 6. The ceiling of 5.2 is 6. Okay. So since the implementation is complex and it provides lots of features with that class, and considering the dynamic nature of Python, these are the reasons why Python is one of the slowest languages, but work is being done on making it faster. So if you want to look at math module, what you can do is you can control click it and it will take you to math module and you can see all the contents of math module. Okay. A lot of these are implemented in C library, that is the C Python interpreter, so you may not see the source code. You will see only the math.py file. All right. So this is the interface file of Python. The actual code is implemented by C. Okay. So with that out of the way, there should be, you should know something about integers. Let's say print 2 into 2 plus 3. So what output do we expect here? So the output expected is 2 into 2 plus 3, that is 4 plus 3, 7. Let me comment this out, okay? And we go to the terminal, new terminal, and we say Python space basics.py and it prints 7. But what if you want to actually add 2 and 3 first and then perform the multiplication? So you can group the numbers using parentheses. And if you run this, it will print now 10. So what this parenthesis does is it overrides the operator precedence. In the operator precedence, we'll talk about operator precedence later also. Star has higher precedence and plus has lower. So when you use brackets, it becomes one expression and the expression will be evaluated first. That is parenthesis overrides the operator precedence and it will be computed separately. So 2 plus 3 will be 5 and then multiply with 2. So that you should take care of. Whenever you are in confusion with the operators, always use parentheses for doing this. Okay. And later on, we will go with all the functionality of MathMod when we will study the standard library. Now, floating points are quite similar. So all the operations which we do on integers, we can do that on floats. Almost all operations we can do on floats as well. Okay. Now, if you want to see how float looks like, float means floating point number. Let me give you examples for that also. So for example, let's make this 2.5 on this one and this 2.3 will make 2.3, 2.4, and let it be, let's remove int of this, and we can give it hours. Okay, and we run. Okay, so see the output of that. Now the surpassing output is here 0.299. Okay, and then we have this as the surpassing output. The 10 is also coming. So we comment this out. Now you see that this output is not 0.3. Okay, this should be minus 0.3, but it is not. So what we can do is, why it is not say 0.3, that's what first to explore. So we, or rather computers operate in binary, and the number system which we use is 10. So we have binary whose base is 10, we have 10 the decimal number system has base 10, and we have two prime factors 2 and 5, and it has one prime factor 2. So when we are converting from decimal to binary, so this is our source and this is our target. Okay, so source number system, and target number system. Okay, consider an example here. 1 by 2 is equal, not 1 by 2, let's say 1 by 3. Okay, from this we want to compute binary. Okay, so if you look at the prime factor in the denominator, it is 3. Okay, now the rule or the theorem says, that number theory theorem, that if you want to convert this into binary, then all the prime factors of denominator should be subset of target number systems bases prime factors. But we see that when we use 1 by 3, 3 is not inside the set of prime factors of the target number systems base. So 1 by 3 won't convert. Okay, if you want. Now that is the reason that this is not coming as 0.3, because it cannot be represented accurately into binary number system even if you use infinite amount of memory. Even if the number of significants between are infinite, it will never terminate. The conversion will never terminate. Your actual conversion formula would be given in your college, so please refer to that. Now we want to look at float function. We look at float. Okay, so we run this, rather we save this and we run it here. Okay, Python space basics.py. So you see, it gives you help on the help class of float, and you can go on all the way to down and you can see all the functions. We will come to these later also, don't worry about it. Okay, now we have discussed floats and integers in small detail here. Now as we see that 2 minus 2.3 is not equal, so you should not do this kind of code. This should be minus 3. Do not use float and comparison. Okay, so this is one reason when the two floats are close by, do not compare them. This basically tests if 2 minus 2.3 is equal to minus 0.3. So don't do this. Don't write code like this. Okay, that is one thing you should take care of. And if you want to explore Python more on shell, what you can do is you can go to your terminal and increase the font. You should install something called VPython. Okay, I have already installed it. Oh, I have not installed it. Okay, I have installed and then OS changed. So BPython is interactive shell. So what you can do is it tells you import. Then there is lots of autocomplete for this. Okay, you can go cycle through them, and if you type math dot, it will list all the usable methods in the function and the classes and everything. So if you say int, and then it gives you the class details. Okay, not everything but class details. We will also see hexadecimal numbers are there. So hexadecimal numbers are given 0x A B C D. We comment this out, and we run this, and okay, I have not commented those out. So ABCD is 43,901 in decimal. So next we have octal, which are 0, I believe 765 would work. So we run this Python space basics .py, and it will print us 501 in decimal. You can optionally change the base, but that is not what I'm trying to prove. Binaries are written like 0B100. This should print 8. Oh, sorry, 4. 4 is what the output is. We have binary support, hexadecimal support, and octal support in Python beforehand. So I think I've covered lots of material in this for a new programmer, and I would like to keep the video short so that you can fit all this into mind. Moreover, if you want to learn more about this, you can go to doc.python.org3. We come here, and you should read the tutorial section of this. Okay, and we can go ahead and read numbers, stuff on numbers. This and text is also there. And if you want to really look at the types, then you have got numeric types. You go through this, and you will see there is a lot of documentation covered for this. Okay, so please go through this, or otherwise you can watch my videos. I have covered all this. Okay, so for example, if you go to youtube.com/c/Shivshankar Dayan, then go to playlists, and you go to Python 3 playlist.
Hello.
And
Hello,
you should,
welcome to this video.
we should pause this. The standard library I have described here. Okay, so there are lots of videos made on standard library already. You can, I should have given better names actually. I'm sorry, this is not very useful. But you should go and look at the standard library discussion. Mostly it is a read through with examples. So there, all of this will be described. Okay, but I will cover numbers in more detail probably in a later video or maybe in a next video. So please wait for that, and I will leave you here. And thanks for watching the video. I'll see you in the next one. Happy programming.